Hello everyone, and welcome back to one of CyberTalents webinar. As most of you know, this is a series of cybersecurity webinars to guide you for getting started in a specific field in cybersecurity. My name is Ahmed Nasir. I'm a technical team leader in CyberTalents, which is a leading platform to rank cybersecurity students and professionals according to their skills by running capture the flag competitions. Today, we are continuing our series and talking about what is required to work in ICS cybersecurity or industrial control system. Of course, if you are not aware about this topic, don't worry, don't panic. This is the right place for you today. Today, I'm very happy to introduce Mr. Omar Sherin. He has 17 years of experience in cybersecurity, especially in ICS or OT. Hello, Mr. Omar, how are you?
Hello, Ahmed. My pleasure to be with you today, inshallah.
Thank you very much. So in the beginning, can you give us a brief about yourself before going deeply in the topic?
Sure. My name is Omar Sherin. I have a bachelor's degree in computer engineering. I started in the manufacturing industry and the oil and gas industries. Then I moved to a national CERT, handling national level incidents in critical infrastructures for 10 years. Then I moved to consulting. I'm currently working with Ernst & Young, one of the largest consulting companies in the world, leading their OT cybersecurity for Africa, India, and Middle East.
Thank you very much for the introduction. So we can now go starting your presentation, please. Thank you.
Thanks a lot, Ahmed. First, I would like to stress that I'm very excited to be with you today. It's a pleasure to talk to new talents, and there's nothing better than at this time in your careers to look forward into what the market really needs in the next 5 to 10 years, and capture that or catch that train ahead of the competition. And I mean the market competition and the competition of people wanting to join the cybersecurity domain. And with that, I prepared the following presentation. I think it will take about 30 to 40 minutes. We will be looking into the following let's say topics. First, we will be explaining what is operational technology cybersecurity, or ICS, why it's important at the global level, and why there is a shortage in the talent market right now, but also expecting this to remain for the next 5 years. After we prove why it's important and how big the shortage is, then we can discuss a little bit about how to start your career journey in that domain, and within the OT cyberspace, what are the different tracks? What are the technical tracks? What are the non-technical tracks? And to start those tracks, we will be sharing a few self-study guides and some publicly available resources and open source materials that you can use to start your journey in that domain, which is very exciting. And also we'll conclude by some professional courses out there that you can, let's say, put in your plan that you take those courses or in your career, actually, in your maybe current employer, you can start putting those plans and those training courses in your training agenda. So with that, let's start. And I wanted to start with an introduction. Probably you might have heard the term OT or ICS, and you might not have heard those terms before. So just to make sure we're all on the same page, and we have, let's say we have the same understanding of the definitions, I wanted to start with that slide. This slide, you will have on the screen few names. We all heard the term IoT, Internet of Things, but also there's OT, there's ICS, there's SCADA, there's DCS, there's PLCs, there's AMIs. So what's the relationship? SCADA, let's start from that unit. SCADA are the mission critical systems that companies and even countries use to run critical services, such as water services, electricity services, managing the electricity grid of a country, petrochemical, how to run a plant, oil and gas, airports, smart buildings, smart grids, I mean smart electricity networks, smart traffic systems, maritime, how to manage a seaport. So those are systems that are running 24/7, doing specific mechanical, chemical, or engineering service almost nonstop. And to run those systems, we use something that can be called, for example, SCADA. SCADA stands for Supervisory Control and Data Acquisition. And for a SCADA system to run, it will often require small computers, programmable, and we call those PLCs, and RTUs, and those will be sensors, and we'll explain that in a second. Those will be sensors that give you, as the operator of that plant or that, let's say, factory, for example, it will give you some information about the pressure, the temperature, the flow of let's say, the ingredients, the output of the product. They will give you those readings and those parameters in real time. PLCs are the computers that take those inputs and make some actions on top of it. And they display all of that, and you can control all of that end-to-end plant from your SCADA interface. If you're running multiple, let's say, substations, electricity substations across a whole city or across a whole country, then you might need a system called DCS. If you are running a smart grid, then you will need something called AMIs, or advanced metering infrastructure, where you introduce smart meters to the mix. All of those terms can be also called, or are part of a family called ICS, Industrial Control Systems, or which I think self-explanatory. It means control systems that we use for an industry or an industrial process. ICS is also part of a family called OT, operational technology, or technologies that run mission critical applications. And as the world evolves and digitization happens, I think the term would be IoT. Everything that is connected, everything that is IP based, will be called IoT sometime, maybe in a couple of years. So I think those are the terms. But the main term we'll be using today is OT, because I think it's the bigger name of the family that controls all of that until that complete merger happens in the future and IoT takes over. But for now, let's stick to the term OT. And when we say it, we mean all the smaller circles inside. So I think that gives an introduction on the terminologies. And when we say what is an ICS and what's an OT systems, those will be systems like you see on those screens in front of you. You will be, when you go to an oil and gas company, you will find a place called the control room, which you can see on the right-hand side. A control room is where the operators, panel operators or supervisors work at 24/7, watching the whole plant or the whole factory or the whole petrochemical company or the whole smart grid or the whole hospital or the whole building, whatever the scope of management. They watch it on the screen, and you can see a sample of that on the left side of the screen. And on those left side, you can see the actual plant in a graphical way. And that plant, you can actually control it using your GUI. It's like a GUI, and you control the plant from that interface. With your mouse and keyboard, you can open a valve, you can rotate a motor at a higher speed, you can, let's say, fill a tank, you can add some gases and ingredients, or add more power to a generator. You can control the plant actually from that interface. But what's behind that interface? Behind that interface is two things. There's a real plant, physical plant with physical asset, like physical machines, physical motors, physical tanks, and there's a software between you and those machines that control those machines. And what we're trying to tell you, that those machines now can be hacked. They can be attacked, and it happens There are many famous attacks, and once you hack those systems, you can control a plant. And I think that's where the game starts to be really serious, because if you are a cybersecurity professional protecting a bank, what's the worst that can happen? Let's think about it. I think in any business, if you're in a company or a bank or any corporate, the maximum thing you can, or the worst thing that can happen to you is that you lose the data. Someone can steal your money, maybe. Someone can steal the confidential information of your company. Someone can steal your credentials. It's all serious, but that's the maximum that can happen. But here, unfortunately, in OT or in ICS, the stakes are much higher. If we lose control or someone gets access to our plant, then those bad guys can cut electricity for a whole city or a whole country. They can, let's say, poison water and kill people. If it's a nuclear reactor, someone can create a catastrophe. If that's a power plant or a petrochemical factory or plant as well, and someone hacks it, he can release, let's say, poisonous fumes that can kill all the people around that plant. If it's an oil and gas facility and someone hacks it, he can cause explosions, and that would kill all the employees, thousands of employees working in that facility. So while the stakes in any environment for IT security, you can lose money, you can lose data. In OT, you lose lives, you lose people, you lose critical services that millions of people depend on. That's why it's very serious. And that's why people working and protecting those assets are, for me, the real superheroes, because you are protecting a country, you are protecting critical service. It's much more, let's say, exciting to go to work every day when you protect those things, believe me, because you believe and you see that you are doing something great, something big, and you're protecting everyone, not just one company. I mean, if you are working for the electricity company, you're not important only for the electricity company. Every business in your country relies on that electricity. The mobiles, the hospitals, the banks, the streets, the schools, everyone relies on your service. So if we protect it and we keep it safe, you are doing everyone a big favor. And I think that gives you energy to work every day hard, because I think you see the value in your job. So how those things actually work, and I won't take a lot of time there, but if we look at the right hand side, and it's a very I'm trying to simplify things a lot here. You can see a valve at the bottom. This can be a valve, a pump, a motor, anything in the actual field. And this valve is sending its readings and parameters to a sensor. We call it RTU, remote terminal unit. Just take an example. Is the valve open or closed? That's one reading I'm interested in. This reading goes to the PLC, or the programmable logical controller, which controls the valve. It's already pre-configured to act on behalf of humans as long as there's certain boundaries. Let's say if the pressure increases to a certain point, please open the valve, and it can do automatically this action. All of those configurations are configured at these ICS servers. So the humans, set the rules at that level. The humans sit in front of that screen, which we called HMI, the one we saw earlier, and they just monitor and observe the whole process and the whole rules that they have set, that they are done in the right way. If there's a problem, and if there's a certain scenario that happens that requires a human intervention, then the human operator, the one we saw in the control room before, can act and step in and override and can take some actions based on his experience, of course, as an operator. All those actions and events are stored in a ledger or in a big database, and that database in our industry, we call it the historian. If we go to the RTU, which is in any, let's say, pipeline, you will find thousands and maybe tens of thousands of those sensors across any pipeline or in any plant or in the water, in the rigs, or in a nuclear facility. You'll find it everywhere by the tens and the thousands. If you take one, and I took a picture of one, or I'm sharing on the screen a picture of one on the left. I hope you can see that that penguin, and I think that means, and it can tell you and give away straight away that it's an embedded Unix or Linux system, and it's you can see that Ethernet port on the top. So it's actually a small computer with a username, with a password, with an IP, with DHCP. So who's securing that, and how quickly we are patching this, and can someone hack it? Can someone lie about the configurations and give it false numbers and false configurations? Actually, this is happening as we speak. Those are the attacks. Those are the most sophisticated attacks out there, not the ones on the banks, not the ones on the websites, not the ones on the let's say ransomwares trying to take your bitcoins. No, those are of course big attacks, but the ones I'm talking about now are the serious stuff. This is state sponsored. This is the biggest threats people need to be worried about, not the other ones. So I think
I think some of the audience sharing some question. Is Stuxnet is one of these attacks?
Absolutely. Yeah, that's a very good question. Absolutely. Stuxnet is the most famous of those attacks, and it's what we call superstar malware. It's very famous. It's the most advanced, most sophisticated, and it requires a team to actually write it and study it. The attacks on OT are very, very targeted because every plant is unique. The temperature, the environment of that plant is unique. So that for the malware to work in the way you want, you have to study your target a lot and make sure that the malware is written for that target. And I think Stuxnet is a great example. It's a malware that will only work in its intended fashion in one plant only. If you take that malware and you put it on let's say any other plant, it will not do the exact function. It will not be as damaging. It will only do the bad things it wants to do in that particular plant because it's designed for that plant. So I think Stuxnet is of course one, but it's not the only one. And after Stuxnet, we saw Duku, we saw Flame, we saw Shamoon, we saw Trisus. There are many OT attacks that are very, very dangerous out there. So we explained a little bit about the definitions. We explained where those systems are actually needed, and we explained that those are responsible to operate critical environments. So how big is the market? I mean, if we're here talking about we're young talents and we want to consider, is this the right domain for me? Is this the right future? Or is this the future I want to be part of? I think that slide shows you that OT is 10 times bigger than IT. In terms of budgets, if we go to a company like a nuclear reactor, their IT budget, if it's $100,000, then their OT budget is $1 million. It's you always, in average, 10 times the IT budget. I'm not talking about security budget. I'm talking about the technology budget. The size of the number of assets or the number of nodes you find in OT is also about 10 times the IT. Because that's the real business. I mean, an oil and gas is not an IT company. IT is serving that business, but it is not the revenue generating service. It is not the core business. This is the term we use in the industry. What is the core business of an oil and gas? It's making oil. So what systems make oil? IT makes oil? No, it's the OT systems that run the well. Those are the systems that make oil, and those are the systems that keep the oil coming. In an airport, what are the what's the core function? It's the air traffic control systems. It's an OT system. It's not the website of the airport. That's the IT. So the OT systems are the mission critical. They keep the business running. They have the biggest budgets, and their people get the biggest attention. The IT systems, and we all know the names of those IT systems. It's like the Microsoft, the Oracles, the SAPs, the HPs, and those are the names we know. But in OT, we find totally different names. We find ABB, Yokogawa, Schneider, Honeywell, Siemens, Allen Bradley, Rockwell. Those are the names that control that industry. Those are the systems that keep the machine running. So another element that you guys need to also look for, which is what's happening around us. So we explained that OT systems are important. They run important things. But let me give you another, let's say, factor. Industries are changing. Industries are changing. In IT, sorry, in the left side, this is the value chain of a utility company, electricity, for example. We used to have 3 companies: one for production, making electricity; one for transmission, moving electricity from the production closer to the city; and then we used to have a third company doing distribution, which is distributing the electricity within the city, within the streets, within the areas or the zones of the city. Those are 3 different companies in the old days. Now, if you look at the scenario of an electricity company nowadays or in the next 5 years, all of those sectors are connected. Production is connected to transmission, is connected to distribution, connecting even to the smart meters at home, making all of this a big, large network, end to end. The old days of having an energy company split into 3 is gone. Now you have giant energy companies that operate automatically with the supply and demand talking to each other. If people want more electricity, that's the demand. They give an order to the production to increase production to generate more electricity. That's the supply. And if it's night time and people don't, in the morning maybe, and they don't want as much electricity, then they tell the production to slow down. So who's making those communications? This machine-to-machine communication. Who is buying and selling electricity? Who is securing those smart meters? Who is securing those communication lines? It's OT systems. So now, if you are smart to look into where the industry is going, and this utility is one example. We're seeing the same in oil and gas. Now, oil and gas is going for autonomous rigs, or let's say fully automated rigs. No people required anymore to stay for 3 months on a rig in the sea. Those rigs can be autonomous. They can be self-managed. No, I don't need people. But what I need is to secure those rigs now, to have secure OT systems responsible for running those systems. So definitely it's the way in the future. And if someone is trying to look for a career at the moment, this is one of the, let's say, hottest areas in the business. And I think we have been seeing this trend of IT and OT coming together, converging, which is the IoT term. So I think it's definitely happening. It started already probably 10 years ago, and it will continue to be stronger and stronger as businesses now require complete automation. And when we say automation, we mean we also need security to secure that automation. And that's OT security. If we look at let's say our region in the Middle East, you'll see that many countries already started to take notice, and they wrote standards to secure such systems. Now, this is in the screen, some of the countries that have already published and announced national, state, or state level security requirements and regulations to secure such systems. Of course, in Europe, yes, we have from ENISA, we have requirements. In the US, yes, we have NIST 882. Internationally, we have IEC 62443. Those are international standards. So it's a proof that this domain is definitely in the focus of governments, of politicians, and of let's say big businesses. Why it's going still to be a problem, and when I say problem, I mean we need to put more resources, we need to put more human capital, and more jobs will be created, because OT is now going through, there's some trends that are affecting the future of OT cyber. We need identity access management for OT. Who is accessing what in an OT system? We need to improve a lot in deception technologies. We need to see what's happening, and we need to see and we need to put some deceptive sensors to see what the bad guys are trying to do. We need to activate and use more of artificial intelligence and machine learning in OT security, because those networks are huge. It's impossible for a human to look at the screen of events and understand everything without the help of a machine. Some OT are going for the cloud. Imagine running an oil and gas company from the cloud. That was crazy to think of 10 years ago. Now there are people considering this. So how to secure that? We're seeing also a trend of blockchain in IoT, and to make sure that each sensor has a stamp that is unique, and any changes in the configurations is pre-approved by the ledger of blockchain. So there are many trends that require lots of let's say innovations and investments, and looking for people to lead those things which are new. I will have let's say a small video. I have a small video here. I will run it. It's showing a smart meter, an experiment in the US by a company called IOActive. You will see green dots. Green dots are healthy smart meters. Someone is trying to release a malware on those healthy meters and trying to infect them. Infected meters will turn into red. So let's see the video and see how it's progressing. So it's a city called Boulder in the state of Colorado. Green dots represent healthy smart meters at homes. Those are homes, actual homes. And the dots represent infected smart meters. Those are 25 smart meters. I mean 25 homes, families, schools, universities, hospitals. And someone is infecting them to shut down the electricity. All the meters are the same model and the same firmware and the same version. Why? Because it's easier to manage same things. And when you are running an electricity company, you will not put a different meter at every home. No, you put the same model, so the maintenance can be easier, the replacement can be easier. But that brings a security challenge. If one vulnerability is found in that meter, then it's vulnerability times 25,000 times, because you can replicate it. The same vulnerability, no more effort is required. Just the same weakness, you can exploit it across all the meters. Now, if we look at the timer, it took 31 seconds. 31 seconds, less than a minute, to infect 25,000 homes and shut down the electricity. It's a big responsibility. If you are the SOC person, the person running the SOC, do you think you have 30 seconds is enough for you to stop such an attack? What tools do you need? What skills? What decisions? If you think of yourself in that position, you're seeing this infection, what can you do? Can you shut down electricity? Can you, what actions do you have? You have very limited actions. So unless security is done properly from the design phase and from the concept itself, then it will be very hard to manage security later. That's why, when we design such things, we need OT experts, OT cyber experts, to plan the smart grid in a secure way, to choose the secure meters, to choose secure communication protocols, and to put segmentation at certain areas. So if there's infection, I can contain it in a particular zone and not to spread it across the whole city, for example. So I think we explained in the second section now why those things are important. I mean, why OT security is important. The third section is about, is there really a shortage in the market, in the talent market, and how big is that shortage? I think all studies mention that there's about 4 million vacancies for cybersecurity, not just OT, but generic cyber. And that's a lot. That means that the whole world have now 4 million cybersecurity jobs that are empty, vacant. They cannot fill it, even if they took all the graduates and put them on the jobs, they will still have 4 million empty jobs. So definitely cybersecurity is the, let's say it's a hot ticket. It's something where you can, or you should consider as your career choice. Absolutely. Now, within cybersecurity, how much is the demand on OT? I think this slide is from Hayes. Hayes is one of the maybe the largest recruiting company for IT in the world. It's a European company, and they just released a report that the top two sectors or domains of cyber growing, or let's say running behind talent, and they are hiring a lot, is the financial sector and OT cyber. Those are the two hottest topics in cybersecurity in terms of recruitment. Financial services, because I think finance is going through a lot with the Bitcoin and the digital currencies and the blockchain. It's crazy, and it needs a lot of brilliant minds in cybersecurity, because now there's no physical security. Banks now don't need safes and dungeons, and no, as you know, it's digital money, and I need to protect money with digital tools. So it requires a different mindset. In OT, I think we explain now why it's important, why it's critical, and the impact of an insecure OT system is huge. It's about lives, and it's about protecting your country. So definitely it's something hot, and companies are really going hard on hiring. So I think we tried to cover now, or we already covered 3 sections. Number 1, definitions. What is OT? Number 2, why it's important. Number 3, is there a real market demand? And I think we've shown few examples that yes, there is a big market demand. So hopefully by now you're thinking, okay, I'm interested. What are the skills that I need to have to go into that domain? And I think the skills, I will break it into 2 parts. I think the skills on the screen right now are the skills needed for any cybersecurity professional, period. Any cybersecurity professional. Any professional in cybersecurity should know network fundamentals. He should understand network topologies and architectures. He should know one or more operating system and how they work. He or she should understand access control fundamentals, Active Directories, and all of that, permissions, username, passwords. He or she should know network security fundamentals. I mean, what is a firewall, how it works, what's an IDS, what's a DPI, deep packet inspection. We should know those things and how they work. We should know endpoint security fundamentals, how to secure desktops and laptops and the endpoints of our, let's say, staff. We should know more about risk assessment, compliance and gap assessment, physical security fundamentals, pen testing, and we should have a CIA mindset. I don't mean the intelligence agency. I mean confidentiality, integrity, and availability. The first word or letter is confidentiality. And a cybersecurity professional should be going to the work every day to protect confidentiality. Then integrity, then availability. I think those are the, let's say, the right sequence. All of them are important, maybe equally important, but in IT, confidentiality is the main driver. So with that, what what do I need to do more or different to become an OT professional? So if we have that, you're a strong cyber professional. What you need to do now is to add to those skills the following. You must be specialized in an industry. You need to choose an industry, and that becomes your first gateway to OT. You should be, or you can be, focusing on one of those sectors: oil and gas, maritime, aviation, building management systems, or smart city concepts, petrochemicals, nuclear, and so on. Maritime, I think it's people have been talking about maritime security for many years, and maritime are the seaports and also the ships. Ships are the big containers have lots of OT equipment, satellite communication, cranes to move those let's say containers and so on. They have lots of engines, hydraulics. So again, this is required for security, to secure as well. I will have, and we have something called operational process knowledge. When we look at a plant, I need to see how the plant works. This is a main differentiator between an OT professional and a normal IT cyber guy. A cyber guy will see computers and servers. An OT guy will see PLCs and RTUs on the same network, and those things will grab his attention, and he will know what this plant is doing. And I will give you an example in a second. So we'll come back to what we mean by operational process knowledge. An OT guy also need to know embedded systems fundamentals, something, or maybe a programming language or a concept like ladder logic. We need to know industrial protocol. So in IT, we have HTTP, we have TCP, IP. In OT, we have Modbus, we have Zigbee, we have IEC 104, we have Profinet, Profibus. Those are OT protocols, network protocols. We need to know how those protocols work and what are the problems of those protocols. We also need to think about safety. You can have a malware in your company and you keep it running in OT, because if you shut down the system, this will impact safety. And safety always trumps in OT, always wins. If there's a problem, you think of safety first, because you're dealing with people's lives. Not like IT, you can restart the machine, or you can shut it down. No, you cannot do that. In OT, you cannot shut down the machine. It has to be fixed. The problem has to be fixed while the machine is running. So safety is a big concept in OT, and getting this in your head is very important. And it's a mind shift. That's why I wrote it in bracket, because it takes time. You need to understand what the vendors we mentioned, the Yokogawa, the Siemens, the Honeywells. You need to know what those companies, those systems of those companies, just like you can be specialized in Oracle or SAP or IBM NetWeaver, or let's say Tomcat, maybe those some products and system and solutions in IT. We have different things in OT. We have Delta V, Emerson Delta V. It's let's say SCADA system from Emerson, the American company. So I need to know how it works. And I can be specialized in Emerson security, for example. It would be excellent if you have some sort of understanding of mechatronics, electrical or mechanical engineering basics. That will be very helpful for you in OT. And the example or the quiz I have in a second will help you to know that flavor. And here the mindset is different as well. Remember we said CIA in IT, in OT it's AIC. A is availability. I need to keep the machine or the system running. Confidentiality is last. So that's again a mind shift. So while IT guys think of, if there's a breach or a data leakage, that's my disaster. My data is leaked. That's my disaster. My confidentiality is breached. No, in OT, it's a disaster when the plant stops. When the machine stops, that's my disaster. Not when the data leaves the company. It's another problem. It's always a problem, fine, but not my disaster. My disaster is the machine cannot stop. So availability is number one. So if you have that, then you become a strong OT cyber professional. I have a quiz now, and it's I will walk you through it. And the idea of that quiz, and maybe Ahmed, you can help me with the answers in the chat, is to clarify this this difference when we said understanding the process that you are protecting. So I will show you in a second a network of a real plant, a real polyethylene plant, which makes let's say an ingredient of plastic, the known material that we all use. And I will explain how this, let's say, engineering process works, and you need to think in a different way. And that, I think, that will help all of us to understand what does it takes to become an OT engineer or OT security engineer. The challenge is, I will explain the plant, and then I will ask you, find the soft spot or the one, like a sniper shot. Where is the single area of the plant that if you hit and you, let's say, kill or disrupt, you make a disaster in that plant? So let's go to that quick quiz. So I think that's it's a very old process, very basic one. From, let me choose maybe 1 second. I chose the laser pointer here. So this is the input here. This side is the inputs. You A, D, and E are ingredients. You push those ingredients. This small icon is a valve. That's a valve. So you open the valves, the 3 valves. You put the ingredients in into this reactor. So that reactor takes the ingredients, mix them with the right pressure, and goes into a condenser. And then it goes into, let's say, another part of the plant that makes some compressions, and it takes, let's say, the bad material out of the reactor. You analyze it, and then you release it. The good ingredients from the condenser go down to the stripper. Stripper also takes some of the impurities, and it goes to this pump, and it goes into the product. So you can simplify it by assuming that the reactor makes some chemical processes, and there's 2 output of the reactor. The bad stuff go here to the analyzer and then out. The good stuff goes to this analyzer and then becomes my final product. So the bad stuff here in the top, the good stuff at the bottom. Some of the, let's say, the very bad stuff that keeps the pressure high on the reactor, we can release it from that purge. Purge, this valve is a valve that, let's say, releases the fumes or the high temperature stuff out of the plant. So again, just a summary: A, D, and E are the ingredients, some chemicals I put into my reactor. The reactor goes to the condenser and then to the compressor. The bad stuff go out, the good stuff remains, and after doing final stripping and to improve quality, I go for the product. Okay, let me ask you a few questions, if you can. So if you, again, on the icons, this is a valve. This is the icon of the valve. This is the valve. This icon is a pump. This icon is a pump. That's a valve. That's a valve. And each one is numbered. So that's valve number 1, valve number 2, valve number 3. This is pump number 11. This is valve number 9, and so on. If you guys are an OT security engineers now, and you want to protect this plant from an attacker that has one shot to blow up the whole thing. If someone wants to blow this up, where are you going to attack, or where is the thing you will play with to cause maximum damage? I will stop now, maybe to give you maybe 10, 20 seconds to think about it, and put your let's say answer in the chat, what is the valve, or what is the pump, or what is the component you would attack to, let's say, blow up that plant. Put let's say, nominated answer in the chat, and maybe Ahmed, you can help me.
Yeah, I
if
think
people
we got
are
the
putting
first
few
shot
things.
here.
Okay, where is what is
the fail? It's a fail in stripper L1.
Failure in L1. Okay, here. Okay, fine.
Yeah.
Any more recommended answers? Maybe let's give another 10 seconds. Sorry, Ahmed, because I'm not seeing the chats.
Yeah, we just got one shot right now. It's from Miguel. He chose L1, and Abdel Karim also shared the reactor.
The reactor. Okay, so I think if I'm an attacker, I will, and I know the process. An attacker on OT, like we said, studies the process. I would attack this one. Let's see the right answer here, which is, I will show you in a second. This one, this valve. This valve is connected to the reactor, and it releases the pressure of the reactor into the purge. If I close that valve, what will happen to the pressure inside the reactor? It will increase. And if the pressure inside the reactor increases, the reactor blows up. And when the reactor blows up, the whole plant blows up because of the pressure of the the liquids and the chemicals inside that pressure. And the energy that will go out of that, it's like an explosion. So if I want to damage this, I would close that valve, and I will hack that PLC that controls that valve and switch it and kill it. If I'm an OT engineer, OT cyber engineer, I'm the good guy, I need to understand this so I can put my attention and focus on this one, not on other things. I need to monitor everything, of course. Everything is important, but what is the most important? It's that one. Why I know it's most important? Because I understood the process. This is the skill number 2, which is we covered here. I will go back to in the slides and show you that skill, which is this one, operational process knowledge. If I know the process, the operational process, then I am a good OT cyber engineer, because I can protect my environment, because I know how it works and what is important. If we go back to this this image, where is the server? Where is the website? Where is the Active Directory? Where's the switch? Where's the firewall? They are there, but it's a layer on top of this. This is the back end. This is the back end of a plant. The switches, the routers, the firewalls are there to protect this traffic. But the bad guys, when they bypass a firewall in a plant, they cannot do anything. They cannot do it. They have to hit that PLC or that valve to make real damage. In the example of Stuxnet, they bypassed the, let's say, antivirus protection. They bypassed the firewalls to do what? To play with the PLCs of the nuclear reactor. To make what? To make it rotate in a wrong speed. That was the scenario of that attack. So this is what really happens, and a good OT cyber understand this and puts his effort in the right location or the right place. So for the sake of time, I have just two more slides or 3 more slides to finish. I'll go very quickly. Now we understood the skills needed. What are the different OT tracks? There's many tracks in OT cyber. You can be specialized in SCADA security or ICS security. You can be in sectors. You can specialize in rail systems, in industrial, in energy, in telco. I mean, OT telco, OT rail, OT aviation, and so on. You can be specialized in security response, in OT network security, in OT security control and identity access management, in OT endpoint, in OT governance and compliance, in OT data protection and privacy. You can be specialized in all of those domains. You can be a consultant. You can be focusing risk assessments. You can focus on managed services. or you can be expert in one of those standards. So there's many tracks, and maybe your journey is, let me draw a line here. Maybe that can be your journey, and it's up to you to choose that journey. You can be an ICS, expert in ICS in traffic systems, focusing on network security, and working for a consulting company. So that might be your career, that you are an expert in industrial control systems, specifically for the rail environment or the rail industry. Your expertise is in OT network security, which is industrial firewalls and industrial IDSs and how to secure the network. And you are working for a consulting company or a system integrator, SI, that implements those products or those solutions or those secure designs. And you can say, you can even something more, you can, let's say, you can have a knowledge of safety in rail, how to protect rail environments from incidents that impact safety of passengers. So that's a journey. That's someone who built his career in that direction and accumulated those expertise. And believe me, if there's someone like this in the market, the value of, by the way, the salary of OT professionals is three times the salary of IT professionals. Because in IT, the risk is X, money, like we said, but in OT, your value is much more. You're protecting a larger price. So, and your skills are much more diversified from the two columns we explained, that you know everything IT knows, plus 9 more things. So I think that's why you become a really hot cake in the market. Okay, some job titles and some OT vendors that people can choose to be specialized in. So you can be an analyst, you can be specialized in compliance, you can be a FAT or SAT engineer, which is site acceptance testing or FAT acceptance testing. And those guys or those people are the teams responsible to test a system before go live. So you run very tough cyber tests on a, let's say, on a rail system before the system is open for public use. So that's FAT and SAT in a simplified way. You can be an OT incident responder. Your job can be to respond to OT cyber attacks. You can be an OT SOC analyst, and that SOC analyst, his weight is in gold, believe me, because this is a person who knows how to handle an incident while the system is running. He cannot shut down. All his skills has to be on live systems. You can be an OT penetration tester. Again, how to test an environment without breaking it. A penetration test always can result in crashing. It's a known risk. How can you do it in a system that cannot crash? So the skills and expertise there is priceless. OT cyber consultant, OT security architect, OT security manager, an OT CISO for a big company, or OT specialized in identity and access management, and physical security and digital security. So, and merging both. So those are some of the titles. That's not a comprehensive list, but just to show you that there is many, let's say, career paths within OT. Some of the names of the products that dominate that space, those are not the Cisco's, I mean the PIX firewalls or the, let's say, McAfee antivirus or EPO or Symantec. No, those are different things. So in OT, we have products from Dragos, from Tefino, from Honeywell, from SPAS, from CyberX, which is now acquired by Microsoft and it's called IoT Defender. And that shows you that even Microsoft is jumping into that space. And once Microsoft jumps into that space, it shows you how big that domain is. We have Waterfall Security that makes diodes and very good firewalls. You have Foxit, again, European company for diodes. Diodes are firewalls that are specifically made for industrial usage, and those are unidirectional firewalls. I mean, they allow traffic only in one direction physically, so very secure. Nozumi is an IDS for OT, security matters and IDS. Indigi, CyberVision, which is acquired by Cisco, and it shows you how, again, how big IT companies realize that there's something big happening in OT, and I need to jump that train or jump onto that train. That's why they are making those acquisitions. Industrial Defender, another very famous product, and FortiGate and Palo Alto Industrial Line. They have firewalls for IT, but they have firewalls for OT to support the OT protocols we mentioned. So if you can work at the client side or at the consulting side on the left, or you can work for one of those companies and become specialized in their products on the right. So again, there's lots of options out there. My last section is what learning materials can I have, free and also commercial ones. So let's start with the free ones. I think if you're watching this, you can use your phone to scan this. Just put your phone, open the camera. Hopefully your smartphone should recognize that QR code and give you the link to a very popular, let's say, page by Robert Lee. Robert Lee is a very, let's say, known figure in OT cyberspace. He's a founder of a company called Dragos, which is one of the names we mentioned in a second ago. But in that, let's say, link, he laid out all the resources that he used to learn OT cyber. So all the basics about the industry, how to understand protocols, how to play with those protocols, how to understand ladder logic, how to understand the processes according to each industry, and so on. So it's a very nice journey. That's his personal journey from someone who doesn't know anything in OT up to becoming an expert. It might take you 6, 7, 8 months to finish all of those materials and use it and get all of this knowledge, but it's a very good collection of knowledge resources. That page or that link as well, if you use your phone as well and you scan it, it takes you to a Tripwire link, and it shows you the top 8 commercial courses. There are courses from SANS. The most popular is called GICSP or GIAC, Global Industrial Security Professional. There's also courses from ISA 99, which is an international body specialized in automation. So you will have at least eight courses or 8 sources of courses. The prices of those courses, those are commercial ones, not self-study. Those are commercial courses, starting from, let's say, $1,000 all the way to $5,000. But again, they are expensive because the demand is very, very high. And once you become certified in one of those courses, your value is believe me, is huge in the market. So that was my last slide. Thanks a lot for listening and logging in. I hope it was beneficial, and I think I will stop now, Ahmed, to take any questions if someone wants to clarify anything. Thanks, Ahmed.
Thank you very much, Omar. Please, everyone, if you have any question, you can put it in the chat of the YouTube channel for the live, for sure. And I got 3 questions, but I believe you already answered 2 of them. The first one is the ICS related certification, and you already mentioned the free one. I think it's free for Robert Lee. And the second one, the GISP, which is the commercial for SANS. And regarding the QR code, don't worry if you missed to scan the QR code. This video is recorded on our YouTube channel, so you can come in later and scan the code. The second question is related to the salaries. As you mentioned, there is one equation related between the IT and OT salaries, which is 10% and 90% for the OT. Is that equation applicable for the salaries also, or maybe something different?
Can you please repeat that? I didn't get the question.
Sure. For the salaries, you mentioned there is one equation, 10% for the the IT budget and 90% in
Yes.
most of the
For the
companies.
salaries, no, it's 3 times, not 10.
3 times, okay.
Yes,
Great.
10 is too much.
Yeah, sure. Of course, it's very much.
It's 3.
Yeah.
Yeah, it's 3 times.
Okay, great. One last question. What is the most common root cause for the ICS attacks? Is it because of the devices is exposed to the internet and could be discovered by some websites like Snowden?
I think that's a good question. I think the main problem in OT is asset visibility. Those plans are so big and so many nodes that even the operators or the owners of those plans, they don't know what they have. And some of them are different protocols, some of them are new systems, some of them are old systems, and there's very weak programs. I mean, I don't mean software by program. I mean like capability to have a visibility of what's happening and what assets I actually have, so I can protect it. The things that are connected to the internet and visible by Shodan, absolutely, that's a fact. But they are visible in many cases because their owners don't know they actually have those, and those things are exposed. They don't know. They are surprised. And to the root cause, because the question is about the root cause, why they are exposed. They are exposed because those companies, they don't know that they have those systems published in the first place. So I would say the publication or reachability through internet is a symptom, but the problem is the lack of knowledge of the operator on what he has and what he doesn't have. So I think in my opinion, that's the root cause.
Thank you very much. 2 more questions. How to get the first job after getting certification? I think this is a generic question, not only for the ICS, but do you have any recommendation regarding this question?
I think if you are already certified in or you are in the training of a certification, you might get your maybe a job very quickly while in training, because the people with you in that course might be from operating companies. I mean, companies who have OT systems, and they send their staff to be certified, and you will be approached while in training. Who are you working for? Are you free? Are you available? Can you join us? I think that's a very possible and very popular scenario in that domain. But if you don't see that happening, and you don't see those people or you don't meet them after that training, I think just updating your CV and submitting your CV to the 4 million jobs we mentioned in cybersecurity, and specifically in OT, you will get a response, I'm sure.
Okay, also one question here is asking, can we specialize in IT and OT of cybersecurity, or just one of them?
Yes, of course. No, you can. And I think I explained in one slide that the basics of both are the same, which is the good cyber skills. Those are the same within IT and OT. If you want to be very good in OT, then you add those 9 different things I added to the bottom right. But for sure, the basics are the same, and you can let's say work in both things and both domains, no problem. But if you really want to be specialized, if you really want to be unique and appreciated and let's say known in your domain by name, then you must have those extra 9 skills. Then when you become, and at that point you will become an OT cyber professional. But the basics are the same, so you can work in both domains.
Okay, at the end, one more question. I think I didn't get actually the question, but you can help us for replying to this one. Do they customize their embedded system architecture? I think he means the operating company or the company using the ICS.
No, that's very good. I think in some cases, yes, they do. They customize their own embedded systems and require specific modifications or set configurations from the beginning. And that depends on the industry. But there's some industries where they don't customize it. like the example I gave with the smart meters. Actually, they ask that all the meters are identical, because it's cheaper for them to, when you're doing a rollout of a smart meter across, let's say, a city like Lagos in Nigeria, or Cairo, or Riyadh in Saudi. You have millions of meters, 20, 30, 10, 15. You have millions of meters. Are you going to buy different configurations for each and every one? No, it's much easier and cheaper and logical from a business aspect to have a unified configuration and same. So they ask on purpose that all of them are the same identical configuration.
Thank you very much. One more. How's the market in Egypt? What about the market in Egypt in ICS? Because you mentioned that the market is having.
Yes. No,
yeah.
I think in Egypt is not yet the OT space. OT domain is not yet popular in Egypt, because I think we as a country haven't yet adopted the digital transformation in the true sense of the word. And when I say that, I mean plants and companies and critical services are more digital, and let's say using some of the some of the new technologies. That's one problem. We're still using the old systems. But there's another problem, that we don't have a standard that makes any operator investing in securing even the old systems. So I think that's the challenge we have in Egypt at the moment. Some countries which are, let's say, more advanced in adapting digital need OT security, because that's the demand of the hour.
Thank you very much. One question: how many countries are using these systems in Africa?
No, every country in the world is using OT. Every single country is using it.
Okay, thank you very much. Finally, thank you, Omar, for the talk and all the tips and tricks you shared with us, and all the advices you shared with the community today. That's really added a lot for everyone here. And thank you everyone for attending our webinar. If you need to follow our next webinar, please subscribe to the YouTube channel, or get more information about CyberTalents, please visit www.cybertalents.com. Thanks again, and have a good day. Bye-bye. Thank you very much, Omar.
Thank you, everyone. Have a great day. Thank you. Take